Hey guys, Garrett Wong, also known as Ensign Harry Kim from Star Voyager, and you're watching Astronomy.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. So tonight might actually end up being a shorter stream than I anticipated because it looks like the weather is turning bad. I started setting up and that's a surefire way to bring in the clouds, tell you what. So, what am I doing tonight? Well, I was going to be trying to take pictures of M87, the black hole. But I do have some things I want to talk about, even if I can't do that tonight, and hopefully some things I can kind of start to demonstrate, but this might actually turn into a two-parter. The weather's supposed to be clear tomorrow night, so if the weather messes things up for tonight, we will simply try again tomorrow night for hunting for the black hole in M87 using the 8-inch LX200 telescope, an S-Big ST2000 XCM, and adaptive optics to hopefully take live pictures of the jet coming out of the black hole that was imaged recently by the Event Horizon telescope. Made some big news in the last week or so, and you can actually see the jet coming from that black hole even with an amateur telescope, although you can't directly see the event horizon of the black hole itself. That was the big news there. It was the first time that the accretion disk and event horizon had been resolved using very long baseline interferometry, which is a way of combining light from multiple radio telescopes all around the world to create a synthetic aperture equivalent in power, resolving power, to a telescope the size of the Earth. So that was the big development there. But even with an 8-inch telescope like what I'm going to be setting up tonight, you can actually see the jet of material accelerating away from that black hole. Alright, so some other stuff I want to address. Over on my Discord server, I monitor deleted comments from various channels, including, at the very top, my own, because, hey, I don't want to be a hypocrite. So, as I've said before, this is not intended to be a position statement that you should never ever delete any comments from videos on your channel. This is simply to provide a record of what gets deleted from various channels, because oftentimes you'll find the comments deleted, although many of them are, say, nasty insults or just spam. Others are actually quite substantive and create and contribute useful information, oftentimes contradicting the claims being made in the video, and wouldn't you know it, poof, those comments go missing. So this is to preserve those comments, and this is really why I created this to begin with, to preserve that kind of information that would otherwise be lost in the interwebs. So, one thing I've noticed, well, I've noticed a couple things, so let's address some things here. So first of all, I should point out that none of the comments you see that have been deleted from my channel were deleted by me, except for this very first one, this test comment up here from myself. And I'm just testing the bot. I had an issue where I had entered the wrong information for my channel initially by accident, substituting an I for an L, or it was either an L for an I or an I for an L, and it wasn't actually recording the deleted comments properly. So I fixed that and tested it, and it was working. And then other comments have gone missing in the meantime. Like this one, I didn't delete that one. And these others from Raven, there's multiple comments from her. And I don't know if her account here, if this particular account still exists. I have a theory that if YouTube deletes an account, they probably have a big red button that they can push to wipe out anything that account ever posted, including comments. So I suspect there's the potential, not guarantee, but there's the potential for that to have been the case here. Because the thing I notice about this, right, is that the bot posted this all on the same day, basically all at the same time. These all came in like simultaneously. As it checked each video, it found all these missing comments from the same account. So it's possible this account got deleted and that's why those comments went missing. Just a theory, but I didn't delete those comments in any case. Neither did I delete this one. This person said he had subbed to my channel and then noticed he was unsubbed from my channel and had to resub. And so I don't know if he deleted that himself or if, again, this is another example of an account that went missing. I think I knew who this is, but so I kind of suspect this is not a case of an account going missing, but I didn't delete this comment. Somewhat appropriately, this comment was actually made on a video that is going to kick off. It's tied into a charity stream that I'm going to be doing. Maybe not tonight, judging by the incoming clouds, but definitely tomorrow night if the weather allows. So I had an interview here with the lead singer for Remedy Drive, a band which some conspiracy theorists claim NASA stole their album cover for a picture of orbital debris damage that was posted by one of their astronauts on Twitter. In fact, this was originally a NASA image, and because it's a NASA image, the government paid for that image, taxpayers paid for that image, and therefore it is public domain. People can use that image for free. And that's exactly what happened. That's why the band used it for their album cover, because it was freely available. It was actually a picture of orbital debris damage on a piece of a satellite that had been recovered in the 80s, and NASA had obviously uploaded that picture to the internet, and this band used it for their album cover. Nothing nefarious or wrong there, but some conspiracy theorists did some reverse image searching when a NASA astronaut tweeted it out again after a hole was discovered on the International Space Station, and they saw, hey, this band used it, therefore proof that NASA fakes stuff. No, not really. Anyway, so I had a really nice interview with the lead singer from that band, and he does a lot of charity work for a charity group called Exodus Road. Exodus Road combats human trafficking, and I'm going to be trying to raise money for them with either this live stream or more likely a live stream to be followed up tomorrow night, hunting for this black hole. So now this brings me to what I really wanted to talk about here, which is in the last couple days, comments deleted from Goose Gatherer on my Falcon Heavy video. So I was able to film the launch to landing of the latest Falcon Heavy, and we have some new news, unfortunate news about SpaceX today, actually. Seems like there was an incident down at the Cape where they were testing the abort motors for one of their Crew Dragon capsules, probably DM-1, the capsule that was recovered after the first unmanned test flight of their Crew Dragon capsule. At least from what I saw, that hadn't been confirmed yet, but it does seem most likely to have been the vehicle being used in that. And seems like they had an accident today, and no one was hurt. There was nobody in the capsule, it was simply being tested, but it does seem like there may have been some destruction going on there, as in the capsule probably no longer exists. Don't know that yet, but there was definitely a big, large cloud seen at the Cape, and it was kind of reddish in color, which is characteristic of hydrazine, which is a toxic fuel commonly used in satellites and spacecraft because it is not cryogenic, so it can be stored for long periods of time. For example, if your spacecraft is supposed to be staying at the space station for 6 months and you want to make sure that your fuel didn't boil off in the meantime, you need a long-term storable propellant like hydrazine. Unfortunately, hydrazine is also difficult to work with a bit and toxic. Difficult to work with in that if it leaks out, people die. So bad stuff to be around. So there was a big red cloud seen at the Cape. Like I said, that's very characteristic of hydrazine fuels, and so it doesn't look good. I'm personally hoping that it was just ground support equipment causing the problem, because this has really high potential to put serious delays on SpaceX's efforts to launch crews into space to reach the space station. They were originally supposed to be launching the first crew later this year after performing an in-flight abort test, and that's what they were getting ready for. So anyway, getting back on topic here to the Discord server, you can see multiple comments went missing from this video, and early this morning I made this comment using my admin account. I don't normally do this, but I wanted to make it clear I'm not the one deleting these comments. He's deleting it himself. In fact, you'll notice he's deleting the same comment over and over again with minor edits. Yeah, pretty much the same stuff over and over again, calling us gullible, saying science is for the gullible, blah blah blah. It's the reason he's doing this, there's two reasons. One, he gets to delete any replies to his comments. People, not just me, were replying to his comments. He didn't like the negative reaction he was getting for his negative comments, so he would simply delete the comment. Boom, all the replies go away. Then he'd repost the comment. So it's his way of actually engaging in censorship. Censorship of things he didn't like, comments being made to refute his arguments. He didn't like that, and so he goes and he deletes his own comment. And so I said, for the record, I'm not deleting these comments. He's also doing it, I think, to make it appear as though I'm censoring him. He probably is aware, he's certainly aware at this point, of this YouTube comment monitor that I run. And so by deleting his comments, he's basically causing them to show up here on the comment monitor. And in fact, here's a new one here. So yeah, he keeps doing this. So he keeps making the same comments. Shills don't like criticism of any kind. Well, that's awfully ironic, don't you think, considering that you delete your comments every time you get a reply with criticism you don't like. I guess I don't know what he's thinking there. I mean, it's just pure hypocrisy. But he's also, I think, doing it to force these comments into the comment monitor, both to flood it and to make it appear that I'm deleting comments. Because if you just came into my Discord server and you didn't know he was the one doing this, you would think, wow, he's really going on a delete rant just like everyone else. No, I haven't deleted a single comment in here except for my own at the very beginning. And I figured somebody was going to use this strategy eventually. I knew this was going to happen sooner or later. Somebody was going to figure out that they could delete their own comments and try to basically delete their own comments to make it look like I'm the one censoring them, to sort of beat themselves up and be able to play the victim card. So I've got a question for the chat. Hopefully there's, if I can get to this other window here. So we got some people in the chat. All right, good. So I have a question for the chat. Sort of an informal poll here, because I want to know what you guys think I should do. Should I ban this person because they are actually engaging in censorship on my channel against my will and out of my control by deleting their own comments and in doing so erasing all replies to those comments? My comment monitor doesn't monitor replies to comments. It only monitors the top line comments. And so by doing this, he's engaging effectively in censorship, blocking all of you from replying to him, and trying to passively, aggressively make it look like I'm the one censoring him. So, should I ban this person from commenting on my channel? I try to avoid that. I actually don't like doing that to people. I'm very slow to ban people from commenting on my channel. In cases of outright trolling and spamming like this, though, personally I think it's justified. But I want to see what you all think. So, hopefully if people can hear me, it sounds like this might be lagging. If people can hear me, I would like to know what people in the chat think. Should I give this troll the boot? Just add him to the ban list and be done with it? Or do I let him continue doing this and hopefully he eventually tires of it? Because for the last couple days he's been doing this repeatedly. So let me see. Okay, so seems like the stream is working good for me. Hi Brazil, hi India. Oh, we got people from all over the world. Good stuff. Okay, we got one vote for block him. Any votes for let him stay? I'll let you guys be the judge and jury on this one. Let the chat decide. While you guys contemplate that, I'm going to try oh dear, I'm going to try to demonstrate how to polar align a telescope. So even if we can't do anything else tonight, I would like to kind of take people through a tutorial of how to do this. There's a fair bit of misinformation going around right now about polar aligning telescopes, the right way to do it, wrong way to do it, at a pretty basic level. And I've never really taken the channel through a tutorial of how to do this before. I've always sort of started my streams right when I'm focusing the camera and pretty much ready to go. There's actually a lengthy process of polar alignment that you normally have to do. So I'm going to try to demonstrate that. Hopefully you guys can see and hear me okay. It looks like the video might be lagging a bit, but as long as the audio is coming through okay, that's all I really care about. So I'm going to demonstrate how to polar align my LX200 Classic. I've got the wedge here pointed north as far as I can tell, just by eyeballing it. In fact, I'll start showing you guys how I do this. Oh. Yeah. It's as bad as I thought. I can no longer see the North Star. That's going to be a problem. But it might pop back out. So I'll just try to proceed here. So I'm just eyeballing it based on where I know north is on my lawn. And you just turn this thing left and right to get it pointed north. Also, there's an altitude, or a latitude dial that's actually over here. On this side of the mount, I've got a latitude dial set to my latitude, so say about 27 degrees north for Florida. Got it locked down at that point. So in theory, this thing is already polar aligned, right? But of course, I haven't done things perfectly. You can't just eyeball this. That's not going to be good enough for a telescope like this, especially if you're trying to do something like eliminate all field rotation. So field rotation is what you get when you don't have a proper polar alignment, or you haven't polar aligned at all if you are using an altitude azimuth alignment, for example, where the telescope is looking up, down, left, and right relative to the horizon. If you do it that way, you're going to get field rotation because you're tracking the stars in two axes, altitude and azimuth. And as you're tracking the stars, even if you're tracking a star in the center of the field of view perfectly, all the other stars are going to appear to rotate from rising to setting over the course of the evening. Now, if you've got the telescope on a wedge like this, or you have a German equatorial mount, something that will tilt it to be parallel with the Earth's axis of rotation, you can eliminate field rotation, but only if you have it accurately aligned. Eyeballing it is not going to be good enough. You're going to get field rotation, residual field rotation, even though you're using a polar mount. You haven't accurately aligned it. It needs to be parallel to Earth's axis of rotation. Depending on how much you are trying to minimize or eliminate field rotation, that will determine how accurate it needs to be. But for deep sky photography, or photography where you're trying to eliminate field rotation over tens of minutes or hours even, you need very accurate alignment for that. You need precision that is significantly less than a degree in error. And I guarantee you right now there's well over a degree of error just by eyeballing it here. Even though I've done this, dozens of times before on this lawn, both on stream and off stream, it doesn't matter. You can't eyeball it well enough to eliminate field rotation and call it good enough. I can't see the North Star right now, so I can't accurately polar align it. But I can show you the basics of how the telescope is set up and what you would go through in terms of accurately polar aligning it. So let me drag out the telescope now, mount that on the wedge, and show you guys how this process works. Alright, so I already had one screw at the top of the telescope pre-threaded that slots into the top of the wedge and holds it in place. Then I add 2 more screws. Thread up 2 more screws into the bottom to hold it firmly. And then finally tighten them all up, do final tightening on these screws to get them good and firm, and the telescope is in place. Alright, I'm just looking. There are a few gaps in these clouds, but it's pretty significant. It was completely clear, of course, when I set up the tripod, the computer, the table, all the other equipment, but now it is clouding up quite significantly. So I think we'll have to push off the black hole observing to tomorrow, but I just want to show the process here. So the next step. Now, this is where the real alignment starts. So, alright, so the way this works, I've got right ascension and declination. Those are the 2 motions of the telescope. Right ascension is this motion. As you can see, I'm rotating the telescope here. When polar aligned, this should be the direction the stars are moving as they rise and they set. The other motion is declination. So if I hold it firm in right ascension, if I tilt it up and down like this, this is declination. So the first step of aligning the telescope is setting the dials so that we are at 0 degrees declination, locking down that drive. So I'm basically engaging the clutch on the declination drive and making sure the dial reads exactly 0 degrees by eye. Again, this is all eyeballing it. Even with a dial, even with a marker, lining it up by eye, that's still not going to be perfectly accurate enough. It'll get you maybe within a fraction of a degree, but that's still not as good as it could be. The final alignment should ideally be maybe a couple arc minutes off at most. So an arc minute is 1/60th of a degree. Now we set the right ascension such that the telescope is pointed directly at the meridian. The meridian is an imaginary line in the sky running from due north to due south. Like that. So now the telescope is basically pointing straight out towards the meridian at the celestial equator. 0 degrees declination. Yeah, these clouds are getting thicker. Not good. Okay, well, this is going to be an abbreviated stream then. So, the next step would normally be to power on the scope and start aligning it based on where it expects Polaris to be, the North Star. And in fact, I'm going to go ahead and grab the equipment and just do that, just to show you the process here. Then tomorrow night we can cut right to the fun. Alright. While I get the telescope equipment out, let me also take a quick look at the satellite and see if there's any hope of this stuff passing us. Hey Sam, what does the weather look like up in your neck of the woods right now? Could you take a peek outside and just let me know? Noah asks if I'm using my typical launch tracking mount. So, for launch tracking, I would use this telescope, usually, but not this mount. I would not polar align it like this. I would use altitude azimuth, because there's no need for polar alignment when tracking a launch. Philip votes, give him the axe. Alright, we got 2 votes for axe him, 0 for keep him. It's not looking good for Goose Gatherer the Troll. Alright, let's take a look at the satellite. Just from glancing up, I'm guessing this is not going to get any better. Alexa lied to me. She said it would be clear tonight. It's not clear at all. You know, it does look like it's moving, but it also kind of looks like it's that kind of thing where it might just keep progressing over. It doesn't really look like it's developing, it's just moving. But it might be a while before it clears up. So, we'll just see what happens. Okay, so I'm going to go ahead and grab some equipment. So, I'm not sure what category of cable this is. This is not the declination cable the telescope came with. I replaced that when it started having trouble. But it is not a standard pinout on this thing. It's like a crossover type deal, but it's not. Is it actually directly crossover? It kind of looks like it is, but I wouldn't trust myself to say those colors are perfectly crossed over. There might be some weirdness to it. In any case, you definitely have to check the pinouts on these things. You don't want to plug a standard cable into those ports. There's 12 volts running through one of these pins, and you'll burn something out if you just plug the wrong cable into it. It comes, of course, with a cable, but these classic LX200s, they're getting old. A lot of times their original cables are starting to fail. We also have the hand controller. This is the old Magellan computer system, not the AutoStar. Alright, given the current state of things, I'm not going to bother putting an eyepiece in the telescope because there's nothing to see. There's just clouds. But I will demonstrate the procedure nevertheless. So I'll go ahead and power on the telescope now. So the telescope is booting up. Alright. So right now I still have it set to land mode for tracking a launch. I'll go ahead and set it back to polar mode. The motors engage. And make sure my site location is set. It is. So the next step is a little bit different than the manual. The manual would tell you to go into polar alignment mode within the telescope's menu. There is a polar alignment mode. I don't use that. What I do is I do a manual slew to Polaris, so it will go to where it expects the North Star to currently be. Okay, so you hear that beep, that indicates the slew is complete. It's now gone to the location, it's now slewed to the location where it expects the North Star to be. The next step in this process is to then align the mount based on where you actually see Polaris. Generally speaking, usually Polaris isn't even in the field of view. When I put the eyepiece in there and I look through, if everything was done perfectly, if the mount was perfectly aligned to begin with, if I had lined up the dials perfectly to the meridian and to 0 degrees declination, and if all of that was absolutely perfect, it should just dead center Polaris done and confirm that I am polar aligned. Most of the time, Polaris is not even in the field of view. So this initial slew is indicating to you two things: how far out of alignment you were on the dials when setting them. That will dictate how far out of alignment the computer is and where it's actually pointing to where it should point. And then how far out of alignment the mount is. So side to side on the mount, and the tilt of the mount can be adjusted as well. And so it will give you a readout of both of those things tied together, and you need to use a method to disentangle them. I use usually the iterative method, where you progressively align the computer and the mount one after the other. So this first motion would be to align the mount, and I mean the physical mount, not the computer's pointing position. So you start off with the assumption that when you had set the dials, when you set it to 0 degrees inclination and you set it to point at the meridian in right ascension, you did both of those things perfectly. And you start with that assumption, and then you work out the errors with that later on. But initially what you do is you simply center up Polaris using the mount. So I would shift the mount physically, left and right, and then up and down and tilt until I got Polaris centered in the eyepiece. Once I have Polaris centered in the eyepiece, then I start aligning the computer. So this is done by slewing to a different star. Ideally, we want a star that is far in separation from Polaris in right ascension, and also close to the celestial equator, reasonably close. Doesn't have to be right on, but you don't want something that's circumpolar. So, for example, here in Florida, we're 27 degrees, 28 degrees latitude, something like that. So any star within 27 to 28 degrees of 90 degrees declination is going to be circumpolar. It will never set. It will always be circling around the north celestial pole, just like Polaris does. So we want a star that isn't circumpolar. We want a star that's closer to the meridian, and ideally not that close in right ascension. And a lot of the stars in the Alexandria Classic database are going to fit the bill, as long as they're properly positioned. So right now, Regulus would be one potential candidate. So I'm going to have the computer move over to Regulus. So you see, it's moved quite a lot in both declination and right ascension. It's much closer to the celestial equator than Polaris. Yeah. Got some sucker holes in the clouds, but nothing really useful. And yeah, now at this point I would align the computer, so I won't touch the mount. Instead, what I would do is I would use the hand controller to center the star. Usually I find at this stage I'm pretty well aligned usually in declination. That's usually not an issue. It's usually the right ascension that's a bit of an issue. And I'm not entirely sure if that's because if at startup I know it will turn the motors, especially right ascension, it will turn it a couple arc minutes in right ascension, and I'm not really sure when it initializes at boot up if it's taking that initial reading for basically determining the digital positioning, or if it's doing that after it does this sort of warm-up motion of the telescope. But nevertheless, it seems like I'm always a little bit off in right ascension, but usually pretty close in declination. So you turn it left and right in declination. I don't know, you can't really see that on the webcam unless I make a larger motion. Usually it's not that far off. Usually it's a tiny motion you can't even see by eye, but it's usually in right ascension, not so much in declination. And you find the star, you align it, and then once you align it, once you've got it aligned in a crosshair eyepiece, and you do want a reticle crosshair eyepiece, not just a regular eyepiece, but an eyepiece that has illuminated crosshairs in it that allows you to very precisely center that star. On the LX200 Classic, you hold down the enter button for a couple seconds, and beep, it aligns on that star. So now I've aligned the computer without touching the mount. Now, this is where the iterative process comes in. The iterative alignment then calls for slewing back to Polaris. So you go back to Polaris. There it is, there's the beep. So now the telescope is aligned back on Polaris. Oops, and I pulled the cable right out of the hand controller. That's not good. Yeah, this cable's not the best. The tab that used to hold the cable in place isn't really there anymore. Fortunately, the telescope doesn't really care too much. It complains a bit, but it's usually all right. So at this point, I don't touch the hand controller anymore in terms of moving the telescope. I simply move the mount to try to recenter Polaris. So usually at this stage, Polaris will now be in the field of view. It will have found it properly. If it doesn't, then that usually indicates you're way off on your initial alignment. You may even want to just start over the whole process of setting the dials back to 0 degrees declination and point at the meridian, and do all of that again and make sure you're close to the right latitude on the latitude setting. Because at this point, if you don't see Polaris, you're going to be doing so many iterations trying to get it right. It's going to be frustrating. It's easier if you're at least in the right ballpark to start with. So at this point, usually I see Polaris in the eyepiece, but it may be a good distance away from the center of the eyepiece. Half the neighborhood cat. I heard something getting killed in the woods earlier tonight. I think the bobcat's on the loose, having a nice dinner on something right now. So I'm just keeping an eye out for the bobcat. We've got a bobcat that lives around here. It's pretty cool. So yeah, at this point, usually the eyepiece has Polaris in it. It can be pretty close to the edge of the field of view, to be honest, oftentimes. So the way the iterative process works is you want to move Polaris not all the way to the center. You want to move it half the distance to the center on each step. That's usually a good rule of thumb. So if it's 2/3 the way towards the edge of the field of view, I'll try to take that down to 1/3 of the way towards the edge of the field of the view, not all the way to the center. And then once I've got it realigned, so I've adjusted it, usually just slight motions to get it closer to the center, I'll go back to the same star I went to before, which is Regulus. So then you slew back to Regulus. Great. So the telescope's pointed at Regulus again. So at this point, you again use the hand controller and you align the computer. At this point, it should be in the field of view. Again, if it's not, you've probably done something wrong. and it may need some adjustment. So you center it up perfectly in the crosshair eyepiece. You center it all the way and hold enter. Centered. Okay, now it's aligned on Regulus. Then you slew back to Polaris, and you just repeat this process over and over again, taking out half the distance between Polaris and the center until it gets to the point that it's pretty close to the center when you slew back to Polaris. And at that point, at some point, you call it well enough. It won't be exactly in the center, but it'll be close, and no more than a couple arc minutes away. So at that point, you call it good enough, and you're off and running. Then you're ready to actually start observing and do whatever it is you're going to do without field rotation, without polar alignment issues. I found, for my purposes, this is good enough to run 5-minute long exposures at f10 with the adaptive optics unit on, and no field rotation, no visible field rotation at all. I've even done up to, I think, 10-minute exposures in some cases, and didn't have any issues. A lot of guys will tell you to use the drift align method. Drift align is nice for a number of reasons. It tends to be very accurate. It's not dependent on the slewing capability of the telescope, and allows you to even theoretically align if you can't see Polaris. But in my experience, it tends to be a slower method. It takes more time. You have to allow a star to drift and then make adjustments based on how it drifts in the field of view on a couple different stars in different positions in the sky. So it tends to be more time intensive, but it is the gold standard method of getting very high accuracy. So if you're going for a permanent alignment, if you're, say, setting up an observatory and the telescope's never going to have to be aligned again, it makes a lot of sense to spend a whole night doing a very precise drift alignment and correct out for as much error as you can until you basically have an absolutely perfect polar alignment. But even using this method, like I said, this is good enough for basically any purpose you could want it for. I've done multi-hour streams of the moon with no field rotation using this method. And then after the stream, I showed the polar alignment, and you can actually test the polar alignment. Once you've got it aligned, you can confirm how well you've got it aligned, and I'm going to show you how you do that. So let's say that you're happy now with your iterative alignment. You think you've got it really well set and right on. So how do you confirm that your alignment really is good, other than just seeing if you have field rotation or not? So, first step, you slew back to Polaris, okay? So, you point back towards, really you're trying to point back towards the North Celestial Pole. Polaris is about 2/3, 3/4 of a degree away from North Celestial Pole. Let's see. Current declination, 89 degrees, 21 arc minutes. So, we are 39 arc minutes from the North Celestial Pole. Really, what you want to do is you want to slew basically directly to the North Celestial Pole. So I'm going to manually specify coordinates until it go to North Celestial Pole pretty much directly. Okay, so it moved a little bit there, and now it's pointed right at the North Celestial Pole. So the way you do this then is you can do this with a CCD camera or an SLR camera, any camera that can do long exposure. You put that on your telescope, either on the main telescope, or if you've got a secondary piggyback refractor or something riding on top, you can use that as well. And then you do two things. You take a long exposure image, and during the exposure, you basically just move it a bit in right ascension. So you just rotate it in right ascension. Usually not that fast, but just so you can see. That's the axis, that's the direction you want to move it. Doesn't matter what direction, but just that's the axis you want to move it in. Not declination, right ascension alone. So you're spinning the telescope in right ascension while the exposure is happening. And so you don't want to run too long an exposure. You won't need more than probably 30 seconds on it. But this will give you a star trail image. And I call this the artificial star trail image because you're artificially streaking the stars through the motion of the telescope, okay? So you have that image. Now, you start a much longer exposure, and you turn off the telescope's drive. So I'm going to tell the telescope that it should go into land mode. This turns off the drives, stops it from spinning. The telescope's not moving at all now. It's not tracking the rotation of the Earth. It's not tracking with the stars. It's just not moving at all. Then you run an exposure like this, and you let it go for, I don't know, 5 minutes, let's say. Enough that you can start to get some star trails. You could even go for 10 minutes, 15 minutes. Depends on how dark your skies are, how sensitive your camera is, all that stuff. You don't want to overexpose it and get a pure white image, but you want to see some star trails. And this is your natural star trail image caused by Earth's rotation. Now you can compare these two. If you're accurately polar aligned, the circles from these two star trail images should be concentric. They should perfectly overlap. If they don't, then that shows where your misalignment is. That shows how far you're misaligned and in what direction. So I've done this before, and with the iterative alignment method, got a wide field image wide enough to pick up Polaris, and yeah, it was a perfect match. The star trails matched up perfectly between those two images. So that confirms that you have a good alignment. So this is how you can prove that you have a good alignment, that you actually did it right. So if you're doing something like trying to show that something wasn't caused by field rotation, you need to do this to be able to demonstrate that yes, you had a good alignment, because otherwise you just don't know, and you can't confirm that your alignment was actually accurate. So for example, if you're taking a time lapse of the moon and you suddenly see an image shift, and I'm not kidding, this has happened, this is currently being debated on a couple of channels right now, where there was a time lapse of the moon appeared to suddenly shift about 20 degrees, and it happened exactly at the same time that the magnification of the image changed. What do you know? It was apparently between two video files that were recorded, or time-lapse videos that were recorded, and at that time the camera was adjusted. The zoom, the magnification was changed, and so there's just no way to know from that whether that was actually some extraordinary event where the moon rotated, or if the camera was simply bumped when it was adjusted. Now, I think everyone watching right now can probably guess which of those two is much more likely, but the argument is being made, or they're trying to make the argument, that no, that was an actual jump of the moon, not the camera. We didn't bump the camera. Okay, but you changed the magnification. Obviously, you had to touch the camera to do that. How do we know you didn't bump the camera? And it sure looks like you did. And also, I noticed after that, it sure seemed like their polar alignment wasn't very good. Wonder why. So this is how you confirm that you didn't bump the mount. This is how you confirm the mount is still perfectly accurately aligned. Everything is good. And you don't have to do this, all night long. This only takes a few minutes of your time. So you can't use the excuse that you didn't do it because you only were wanting to watch the moon. Okay, that's fine, but you can still do it after you watch the moon. Before you tear down the telescope, before you start taking things down, you can point it at the North Celestial Pole and do this for confirmation purposes. So that's how you do that. So now people can see this video and see that's how that process works. Unfortunately, what we can't see tonight is the black hole in M87.